Let's review together what we did this week to as far as review. I would encourage you to go over the notes once again and do this exercise together with me. The first problem requires you to convert a quadratic equation, this particular one, into vertex form, and then to graph it and find the number of points on the graph. Use both forms to actually fill the table below. So in order to find to convert into vertex form, we have to do a number of passages. The first one is inspect A, that is the multiplier of x squared, and verify that that is 1, and actually in this case it is. So what we will do is just rewrite the equation and x squared as x squared plus 4x, and we are going to move the minus 7, the constant, into the other side of the equation, so we're going to write it as y plus 7. Now we'll look at b, and we will divide it by 2. That gives us 2, and then we square it. 2 squared, that would be 4. And then we use this 4 to complete the square, and we add it to both sides of the equation. So this would be rewritten as x squared plus 4x plus 4 equals y plus 7 plus 4. This trinomial is a perfect square. It can be rewritten as x plus 2, and the 2 is actually our b divided by 2 square equals y plus 7 plus 4, 11. This is basically done. The only thing we have to do, remember that the quadratic the vertex form of the quadratic equation is it needs to be written as y equal a that multiplies x minus h square plus k, where h and k are the coordinates of the vertex. So to write the equation in that form, we need to move terms around, and we're going to write like y equals x plus 2 square minus 11. One thing that you should notice is that a is non-existent. A is 1, like we have here in the standard form, and this is it. This is done. So our vertex is located at minus 2 minus 11. So if we were to write the graph, the graph looks like this. Would be a parabola. This is our vertex, and this is minus 11, this is minus 2, and the y-intercept right here can be found very easily by inspecting the standard equation of the parabola and noticing that c is minus 7, and we know that that's our y-intercept. So we can scroll down just a little bit, and we can write the vertex point at minus 2 equal minus 11. Those are the coordinates. Y-intercept is minus 7, and the symmetric point to the y-intercept would be this point on this side, and as we know, this will have the same y as the y-intercept, and we know that the distance between the vertex and that point are going to be exactly the same. So the only thing we need to do is multiply the vertex, the x coordinate of the vertex by 2, So the y-intercept is located at minus 4, so symmetric point to the y-intercept is located at minus 4, minus 7. What about the axis of symmetry? The axis of symmetry is the axis that goes through the vertex, and it's x equals minus 2. X equals minus 2. We finished. This is the first problem that was done. Let's tackle the second one. We need to solve this quadratic equation by factoring. Okay, we have to solve the equation. We need to make it equal to 0. We have a 4 on this side, so we need to move it on the other side, and that means that we need to rewrite our equation as 7t squared minus 15t and plus 2. Now, to factor, and I'm going to use the reverse box method. We need to find, first of all, we need to find the factors of AC, A times C, that is 7 times 2, that equal B, that is minus 15. So factors of A times C that add to B. So in this case, we need to factors of 7 times 2 that add to minus 15. And let's look at the factors. If you think just 1 second, you will see that the only thing that works is actually minus 1 and minus 14. If we multiply minus 1 times minus 14, we get 14, and if we add them up, we get minus 15. So using the reverse box method, I'm drawing my box, dividing in 4 smaller boxes. The first box gets the first term, t squared, and the box on the right bottom side gets the c term, so that is 2. Here we put the two factors that we just found, so minus t and minus 14t. Now we look at the first row, and we find the greatest common factor for the first row. In this case, you can tell that the greatest common factor is actually 7t. Then we look at the greatest common factor of the second row, and in this case, the only factor that we have is 1. And as a matter of fact, we should write minus 1 because we are touching a negative box. So every time we touch a negative box, we will have a negative greatest common factor. We do the same thing for the first row. Sorry, for the first column, we find the greatest common factor. In this case, the greatest common factor is t, positive t, because we are touching a positive box, and the greatest common factor of the second column is minus 2. Again, 2 would be a factor, but we are touching a negative box, so we need to make sure that we write a minus 2. So this equation can be rewritten. We have found the two binomials. We can rewrite the equation as 7t minus 1 that multiplies t minus 2. So what are the solutions of this equation? Well, it would be t minus 2 equals 0 and 7t minus 1 equals 0. That translates into t equals 2 and t equals 1/7. Now let's move to the next one, the next equation. The next equation can be again solved by factoring and by doing exactly the same thing that we did before. We need to find the factors of a times C that add up to B. So in this case, 4 times 9, they add, the factors of 4 times 9, they add to 12. Okay, so 4 times 9 equals 36. The factor 36 that add to 12, 6 and 6. So we, using again the reverse box method, we are going to find the two binomials. Okay, the first box gets 4n square. This box down at the bottom on the right gets the 9. On this side we write the two factors, 6x and 6x in this case. Greatest common factor, sorry, I'm so used to writing x that I made a mistake here. I should be writing n in n. So 6n and 6n. Greatest common factor for the first row, it's 2n. And the greatest common factor for the second row is 3 in this case. If I do the same thing for the first column, the greatest common factor would be 4 and 6, it's 2n. And greatest common factor on this column would be 3. So my my two binomials would be 2n plus 3 that multiplies 2n plus 3, and my solutions would be n equals minus 3 halves and then rho equals minus 3 halves. In this case, I mean, if you are unsure, as I keep saying, if you are unsure that your factoring is correct, you can always FOIL the two binomials and see if you get the same solution. Sorry, the same equation that you started with. So let's do this in this case. For example, I multiply this by this, I multiply this by this, and then I multiply these two terms and see what I come up with. So the first thing will be 4n square plus 3 times 2n is 6n. Then I have plus 6n, and the other term 3 by 3, 9, plus 9. So as you can see, we are in pretty good shape. 12n plus 9, and those two equations, this equation and this equation, do match. So we did a pretty good job, I guess. Exercise number 4. In this case, we are doing the reverse. We are trying to we will find the equations, the algebraic form of the parabola given a graph. Okay, let's look at the points that we have, that we know. We have the intercept, the y-intercept. We have the solutions, the vertex. So we have quite a bit of information already. As you know, the equation in factor form, it's can be written as y equals a x minus q x minus p, where q and p are the the x-intercepts. How can we find a? A can be found by we can use the method of a equals delta y divided by delta x square. So that is by picking 2 points that we can easily read on the graph. Let me write it. We can find 2 points that we can read easily on the graph, and then we find the delta y and delta x. So let's pick the vertex, and I guess this point right here. We have delta y in this case is 1, 2, 3, and 4. So we have 4, divided by delta x, 1 and 2, 2 square, that's 4 divided by 4, so our a in this case is 1. And we know that the x-intercepts in this case are two times the same intercept. This parabola touches the x-axis twice at 2. So we can rewrite this equation as y equals 1, our a, then multiplies x minus 2, x minus 2. Done. Equation in vertex form. We know once again the vertex form is a, then multiplies x minus h plus k, where h and k are the coordinates of the vertex. We know a, we know the coordinates of the vertex, so we can just rewrite this very quickly as 1, then multiplies x minus h. The x of the vertex is 2, so minus 2, and the k of the vertex, the y of the vertex is 0, so k is 0. If I were to write it correctly, this would be, sorry, this is a squared, this is squared. If we were to rewrite it again, I would write it as x minus 2 square. That, by the way, it's same as x minus 2 square. It's the same, in this case it's the same as the factor form. In standard form, we can foil the factor form if you want. We can look at the graph, look at the y-intercept. I would just foil it and or square this binomial, and we find a standard form that would be ax minus plus bx plus c. So if we foil it, we'll get y equals x squared minus 4x plus 4, and this is our equation in standard form. What is the y-intercept? Let me scroll down just a bit. But first of all, you can see it from the graph that the y-intercept is 4, but we see it also from the c. So y-intercept, it's 0, 4. Symmetric point to the y-intercept, we can see it from the graph, and that would be 4, 4. But again, we can find it also algebraically by multiplying. We can find the x algebraically by multiplying the x coordinate of the vertex. So and we know the x coordinate of the vertex is 2. 2 times 2 is 4 in this case. However, we can easily see it from the graph. The axis of symmetry is the axis that splits the parabola in two, is this line down here, and its x equals 2. It's pretty fast. We finished the first problem. I would advise you to go ahead and do the other one. If you have not done it already, the partner practice P on your own, following the directions I just gave you.